Hello, students. This is Mr. Rich. Sorry about the delay in getting started. It's about 7:06 p.m. here on Sunday, the 20th of April, and I'm going to be going over an AP Calc exam here. And what I've got here are some free response questions. Now, the free response questions that I've picked to go over tonight are a very interesting set of problems. These problems were put together by a fellow by the name of Brian Passwater. You may have seen his name at some point in AP Classroom. He does quite a few videos, I believe, and he just is involved in creating a lot of good content for students in AP Calc and AP Pre-Calc, and probably Calc AB and BC, if I'm not mistaken. But what I'm going to do here is I'm going to go through this set of free response questions that he did for the 2020 AP Calc students back in the time of COVID. So back right after COVID hit, everybody was online, and College Board had to scramble on how they were going to actually test the students this year in a remote environment. They were totally unprepared for this, as most of us were when the pandemic broke out. But what he did, he kind of knew what the test was going to look like in terms of the format of it. And so he put together this exam review that was really clever, because it covered all of these questions, covered all 8 units of the test in a really interesting way. So I thought it'd be helpful to go through these in the next hour. And we'll be covering most of the main themes from units 1 through 8 in AP Calc AB. So let's just dive right in. And if you don't know me, I am a former high school math teacher. I taught in Duval County at Stanton College Prep for about 6 years, and I taught AP Calculus and AP Stats. And right now, though, I am a full-time math coach, and I coach all high school math from Algebra 1 all the way through Calculus, and do stats and just about everything in between. And I do a lot of ACT, SAT math prep. So that is who I am, and that is what I'm going to do today, is go over this test. This, as I recall, this is a non-calculator test, and we won't need a calculator. If we do, I will pull one up here on the screen. So what we're going to do is we're going to answer all these questions, and all of the questions are free response, and we're going to get answers 0 through 9. There are 10 answers, and they all are going to be 0 through 9. We'll cross these off as we go. So the first question is a piecewise function. It says, let f be the piecewise defined function above, where k is a constant. For which value of k is f of x continuous at x equals 2? Well, in order for us to determine what k has to be, what they want to see on your free response questions on the AP exam is they want us to actually use limits here. Because in order for the function to be continuous, we know that the limit, as we approach 2, the limit has to exist, and it has to be equal to the function evaluated at 2. Well, in order for the limit to exist at x equals 2, right, in order for this to have a value, what you learned in Unit 1 is that the limit as you approach 2 from the right has to be equal to the limit, of the function as you approach 2 from the left-hand side. So that's going to be the equation that we're really going to use here. Is this is going to be my function to the left, and this is going to be my function to the right of 2. And so that is what I'm going to do. And I want to make sure that my mic is all set up here. Okay, yeah, we're good to go. Now, what I'm going to do is I'm going to go up here to the portion of the function, of the piecewise function that is just to the right of 2, and I'm going to do direct substitution and put 2 in for x. So that's going to give me k squared times 2 minus 5k plus 3. And then on the right-hand side, as x approaches 2 from the left, that's going to be this one. I'm also going to use direct substitution and plug 2 in for x. So that's going to give me equals 2k minus 6. That is a quadratic function with k. And so what I'm going to do is I'm going to solve this for k. This is going to give me 2k squared minus 5k plus 3 is equal to 2k minus 6. Since it is a quadratic, I want to get all these terms over to one side. So that's going to be 2k squared minus 7k plus 9 equals 0. And we're going to solve this now for k. My k doesn't look like a k there. All right. We're going to solve this by factoring. I'm going to use, I would call this factoring by trial and error. I know that I do need two negative numbers because the product of 9 either has to be both positive, both negative, but the middle term is a negative. So these have to be two negatives. And I think that is going to work if we do a 9 and a 1. Let's see if we have this right. It's a negative, negative 7k has to be 18, which would be 6. Let's make sure we get this right. Let's go back up here and make sure that doesn't look to be quite right. So 2, this is incorrect right here. 2kx. So this is going to be 4k right there. So this becomes 4k. And then that's going to give me 9k right here. Negative 9k when I subtract that 4k over there. Okay. And if you are here watching live, go ahead and put a note into the comments if you're able to, so I know that you're here. I think we've got a few people here watching live. All right, so now what I'm looking for here, I got to have a 9 right here. So if we go with 3 and 3, right, that's going to give me, my outer product is going to be a negative 6k. The inner product here is a negative 3. That's going to give me the 9k. So when I set both of those equal to 0, I'm going to get an answer of 3 halves, and I'm going to get an answer of 3. But now what I need to do is I need to see which one of those would actually be the one that we want. Now, what is f of 2, right? We have to come up here and say, what is f of 2? Well, f of 2 is going to be k squared minus k. So it's not even a function of x when x is 2. So let's try 3 when k is 3. If k is 3, f of 2 when k is equal to 3, that's going to give me 3 squared minus 3. That's going to give me 6. Let's find f of 2 when k is equal to 3 halves. Well, that's going to be 3 halves squared, k squared, minus 3. That's going to be 9 fourths. Minus 3 would be minus 12 fourths. That's going to give me a negative 3 fourths. So I have either f of 2 is going to be either 6 or negative 3 fourths. So what I want to do then is see which one of these k values is going to be really what we want. So we have to go back up here and see, gosh, what happens if k is 3? That's going to give me a 6. Do you see that? So I'm going to say, what is the limit as x approaches 2 from the right when k is equal to 3? From the right-hand side, and I'm going to do it from the left-hand side just to make it a little bit easier. I'm going to use this one up here. So as you approach 2, when k is equal to 3 of f of x, that's going to give me 2 k is 3, but x is 2, minus 6. That's going to give me 6, 12. 12 minus 6, 6. Yeah, and that's going to give me a match, right? So I want k equals 3, not k equals 3 over 2. Okay, and so that is the answer for k that would make this continuous, because the limit as I approach 2 is going to be 6, and f of 2 is going to be 6, making this a continuous function. And so we can cross 3 off as one of our answers. All right, let's keep moving on. Hey, Sadie, how are you? Negative 3 over 2. Well, I think if you're talking about k, yeah, k, I think I want my answer to be, though, 3. So I had 2 options is what I had there for my k value. And 3 over 2 is, now we could try 3 over 2 to see if that was going to give us the same answer, but k equals 3 was the one that we're looking for. For f of 2 when k, for when f of 2, k equals 3 over 2. You got a negative 3 over 2. Okay, yeah, good. Thank you. Yep. So when you plug that in, then it confirms that that's not going to be our answer. Okay, awesome. So let's go to part B here. It says the graphs of f and g are shown in the figure above. If h of x is a different function, f times g, find the value of h prime of 1. Well, in order for me to get h prime of 1, I need to find h prime of x, and I'm going to have to use the product rule. So this would be the kind of a problem that you would see on a free response, that they want you to show that you understand that the derivative of this is not just the product of the two derivatives, f prime times g prime, that instead is going to be the derivative of the first times the second plus the first times derivative of the second. And the order that you put these products in doesn't matter. It's just that we have to have derivative of one and not the other, and then switch it around on the second one. So that's what that's going to look like. So then what we're going to do is we're going to say, well, h prime of 1 is therefore f prime of 1 times g of 1 plus f of 1 times g prime of 1, right? And we're using the figure above here. So f prime of 1 right here is going to be the slope of that line, right? Because the derivative is the slope of the function at that x value, and it's a linear function. So we just have to calculate the slope. So it looks like our slope here is going to be a 2. So we're going to plug in 2 for f prime of 1. G of 1 is just the y value at x equals 1, and that looks to be a 3. And if you're watching this, I like Sadie. She's working this as we go, and if I make a mistake, please let me know. F of 1, then wait, I think I did make a mistake here, because G, yeah, no, we didn't. We're good. G of 1 is up here. Now, F of 1 is down here at negative 1. And g prime of 1 would be the slope of the g function at x equals 1. And that slope looks to be a negative 1. So this looks like it is 6 plus 1, or an answer of 7. And so we're going to cross that off of our list here. Okay, so that's it. So keep in mind, and I'm sure your teacher is coaching you on this when it comes to the free response questions, you do want to show your steps. You want to show your work, right? You would, if you didn't write this down, I'm quite convinced you would still get full credit if you went straight to what h prime of 1 is. But I like to start off, before I plug this x value in, I like to go ahead and just do the derivative and then plug in, and then show the continuation here, right? Equals, and then you're plugging in the numeric values for each part of the equation that you just created. All right, letter C. The radius of a circle is increasing at a constant rate of 2/3 inches per second. At what rate in inches squared per second is the area of the circle increasing at the moment when the circumference is 27/2 inches? So this is a related rates problem. And let's go back and quantify, or I should say maybe categorize the quantities that they've given us. If the radius is increasing at that rate, that is a dr dt. The radius, the rate of change of the radius is a positive 2/3 inches per second. They're wanting us to calculate dA dt. That's the quantity that they want. At what rate in inches squared per second is the area of the circle increasing when the circumference is 27/2? So this is going to be at the moment in time when the circumference is 27/2 inches. Well, if I want to get the rate of change of the area of a circle, then I want to write down the formula for the area of a circle, pi r squared. I am then going to take the derivative of that with respect to time. So that would be dA dt, right? The derivative of a would be the number 1, but by the chain rule, you're multiplying by the derivative of a, which is dA dt with respect to time. So it's dA dt. The derivative of pi r squared, pi is a constant, obviously, so I can go ahead and take the derivative using the power rule of derivatives. So it's going to be 2 times pi times r to the first power, but by the chain rule, I have to multiply that by dr dt. Because remember, what we're doing here is we're taking the derivative on both sides of this equation with respect to time, right? So that's kind of the move that we are doing here on a related rates problem. And then once we execute that derivative on both sides, this is what we have. Now we know what dr dt is. We're going to make a substitution of 2/3 right there. But now we need to know what 2 pi r is. Now here's something really interesting. The circumference of a circle, right? And by the way, you won't be given formulas for circumference and area of a circle on this test. You are expected to know those. But circumference is 2 pi r. And notice that when we took the derivative of the area, we got an expression inside the equation there, 2 pi r, which actually I can go ahead and substitute 27/2 in for 2 pi r right there. So my calculation ends up being dA dt is 27/2 times dr dt, which is 2/3. The 2's divide out, 3 goes into 27 9 times. So really, my answer here is going to be an answer of 9, right? And this is going to be certainly inches per square second. Inches squared per second. So there it is. So that means then in our little scheme here, we can cross off the number 9. We have an answer for number 9. All right, so we have a few more people who have joined us. And again, my name is Mr. Rich. I am a math coach here in Jacksonville, Florida, and I tutor students in high school math from Algebra 1 through Calculus. I'm a former math teacher at Stanton College Prep. And today we are doing an AP Calc set of free response questions from 2020, the year of the pandemic. And these are problems that were put together by a teacher named Brian Passwater. And these are an excellent group set of, and you can see his name and email address down here, but these were set up for you to do some free response questions that covered all 8 units of the class on the major themes. And so we are now going to what is our 4th question of tonight. I'm going to try to wrap this up by 8 o'clock is how far we're going. And let's keep going here. Part D, It says, for t from 0 to 5, a particle moves along a horizontal path with velocity v. Selected values for velocity are shown in the table above. Use a right Riemann sum with 3 subintervals indicated in the table above to approximate the total distance traveled by the particle from 0 to 5. Okay, so a couple of things here. Total distance traveled is going to be it's going to be the integral of the absolute value of velocity. So when you do one of these problems that's asking you to do a right Riemann sum or a left Riemann sum or a trapezoidal sum, what you want to do is start off by giving the formula that you would use. Now, I would start this off by saying total distance traveled, TDT, is going to be the integral from 0 to 5, because they're telling us to find the total distance from 0 to 5. Now, what I'm going to do is I'm going to take the antiderivative of the absolute value of velocity. So I'm showing the grader that I know that it's absolute value. Now, why do we do the absolute value on total distance traveled? Remember that total distance traveled means we want to know how far the object is traveling without respect to whether it was moving right or left. If you were to take the integral of just velocity and the object is moving both right and left, you are going to end up not with total distance traveled. You will have something less than that, a number less than that, because you will get what's called displacement. So if the object moves 18 units right and then 5 units left, your answer for the integral is going to be 13, because you'll get a positive 18 and a negative 5 when you integrate. But really, if you go right 18 and then left 5, that's a total distance traveled of 23. And so what we do is, for the portion where the object is traveling left, which would give me a negative integral, then what we want to do is turn that part of the calculation positive. So we're just simply adding the absolute values of each section of the integral. Now, what I'm going to do is I'm showing that's the formula for total distance traveled. I'm now going to say that that's going to be approximately, because we are doing a Riemann sum, which is going to be an approximation. And since it's a left Riemann sum, and I'm using 3 subintervals, I make my bases of 3 rectangles here, and I'm going to put the intervals in here. So from 0 to 1 is 1 second, from 1 to 3 is 2 seconds, and from 3 to 5 is 2 seconds. But the height, these are the widths of the rectangles for my Riemann sum. The heights of the rectangles is going to be defined by the right edge of the rectangle here. And so what I'm going to do is I'm going to take 1 times the height of the right edge. So this is going to be 1 times 2. Then I'm going to take the width of the second rectangle and multiply that right here by the right edge height of 1. So that's going to be a 2 times 1. And then here, I'm taking 2 times the absolute value of 1. So I'm going to show the grader I am taking the absolute value of that negative 1. Okay, and then I'm going to say that this is equal to, and that's going to be 2 plus 2 is 4, plus another 2 is 6. And this is going to be 6 meters. That is my answer for this problem. And we can come up here and cross off the number 6. Okay, and that's how you want to lay out your work on a Riemann sum. If you are watching live and you have a question for me, or if you see me doing something you don't understand, or if you think that I just made a mistake, then I've already made a few here tonight. Be sure to put a note. I can see the comments here if you're posting in YouTube. Okay, next question. All right, the graph of f prime of x, the derivative of f of x, is shown in the figure above for the interval 0 to 8. At which value of x does the graph of f of x have a local minimum? Well, local minimums, or what we call relative extrema, relative mins, relative maxes, are going to occur at the critical values for f of x. Those critical values are defined to be the spaces where, or the points where the derivative is 0 or undefined over its domain. Well, the critical values here on the open interval between 0 and 8 are going to be here at 4 and 6. So I have relative extremes at those two. But my local minimum is going to occur. Think about local minimums here. If you have a function, now remember, this is not f of x. This is f prime of x. So now I'm looking at some f of x. I'm just drawing some random function. Okay. And if this is f of x and this is a local min, and it is, that's the place where it changes from being a decreasing function to an increasing function. At that point, it switches from decreasing to increasing. That means the derivative was negative because it was decreasing, and then the derivative changes to being positive on the other side of that relative min. So when I'm looking at the derivative function for a relative min, I'm looking at where the derivative changes from being negative to positive. And that's what happens right here, right? To the left of 4, the derivative is below the x-axis, meaning it is negative, and then it's to the right of 4, the derivative switches and goes above the x-axis, or positive. So this has to be the location of a relative min. 6 would be a relative max because the derivative was positive to the left, and then it switched and became negative to the right. So that means it changed, the function f of x changed from increasing to decreasing. That'd be a relative max. But the key here is not just identifying it, but it is to also explain or justify why that is. Now, in this free response question, they did not say justify your answer, but I can tell you on an actual free response question, almost always, they're going to put the word justify. All right, so we will justify this, but we will say, here's my answer here for the grader. F of x has a local min, has a local min at x equals 4 because f prime of x changes from negative to positive. That's all that you need to state. The implication when we say changing from negative to positive means as we're moving from left to right, the derivative changes from being a negative value to a positive value. Excellent. Let's go to F. Let G. Oh, so okay. So 4 was our answer there. So as we following our trend here, we can cross 4 off. So 1, 2, 3, 4, 5. So we are halfway through. Let's keep moving on. Let g of x be the solution to the differential equation dy dx equals 2xy through the point negative 3, 1. If g of k is e to the negative 9, where k is a constant, find the value of k. Well, for sure. I mean, you're going to have a free response question that is going to require you to solve a differential equation. And hopefully in your AP Calc classes, your teacher is giving you plenty of old past prior AP free response questions for you to work on. And you want to work a lot of the differential equations because you know those are going to be there. Well, when we solve differential equations here in AP Calc AB, we're using a method called separation of variables. So what I'm going to do is I'm going to get the y that's in this differential equation over to the left with the dy, and I want the dx to be over with the 2x. So this is going to be dividing by y on both sides and multiplying both sides by dx. I separate the variables like this. And then, as you learned in this semester how to solve this equation, because remember, a solution to the differential equation is going to be a function itself. I want to solve this for a function of x, where I get y on one side of the equations. So We integrate both sides. There we go. So we have to take the antiderivative on both sides. Well, the antiderivative of 1 over y dy is the natural log of the absolute value of y. Over here, the antiderivative of 2x using the power rule, bumping the exponent here, which happens to be 1, bumping it up to a 2, and then dividing by that new exponent gives me just x squared. And then we put a constant over here. Now, it is true that both sides really do get a constant when we take an antiderivative, but it's just by convention we decide we'll combine both of those constants over on the right side by one other constant that we call c. And then what I'm going to do to figure out what this c constant is I'm going to use this 1 point. All right, so they're telling me that they want me to find the specific solution that passes through this point. Because you can see this is what we haven't really solved the equation for y yet, but this is when we ultimately solve that for y and we leave the c there, that's what we call a general solution to the differential equation. And c could be any number. Therefore, there's really an infinite number of solutions for the differential equation, unless we specify one of the particular solutions that passes through a particular point. Because this, given that point, that allows us to find out what c is. And so it allows us to zero in on one particular solution to the original differential equation. So I'm going to plug the 1 in for y. So that's going to be the natural log of 1. Natural log of the absolute value of 1, which is absolute value of 1 is 1. And then that's going to be negative 3 squared plus c. Well, natural log of 1 is 0. And negative 3 squared is 9. And so c is going to be a negative 9. All right, now, okay, so we're going to solve this, and then we'll take care of the g of k equals e to the negative 9. We have to find k. Kind of a weird question. And that one might not make a lot of sense, but I'm not going to let that distract me from what I need to do, and that is to solve this differential equation. I now know that it's the natural log of the absolute value of y is equal to x squared minus 9. What I do next is I'm going to exponentiate like this. And when I exponentiate, that is going to leave me just the absolute value of y, right? Those are going to cancel because they are inverse operations, e to the power and log base e. This leaves me e to the x squared minus 9 over here. This is an exponential function, so it's going to always be positive. So I'm going to go ahead and drop the absolute value there. We have that. Now, what I can do is I'm going to go ahead and rewrite this as, remember, this minus 9 is in the exponent. So I'm going to rewrite this as e to the x squared over e to the 9 power. Because if you have subtraction in your exponent by the negative, or I should say by the quotient rule of exponents, subtraction in the exponent would have been caused by the fact that you were dividing like bases. All right, so what I'm going to do now is say, okay, that's really going to be my function. I'm going to say my function y, and I can see there's e to the minus 9 right there. So I'm going to say e to the minus 9. I'm going to bring that up times e to the x squared. And we'll call this our f of x. And let's see, was this a g? No, it was g of x, right? So this is g of x. Now I'm going to try to answer their particular question. They said if g of k is equal to e to the minus 9. Well, okay, I'm just going to do what they say, right? If g to the k, well, what would g to the k be? It would be e to the minus 9 times e to the k squared. Well, in order for g of k to be equal to e to the minus 9, this has to be equal to 1. So it's pretty easy to see that k has to be 0 because e to the 0 is what's going to be 1. So my answer to their question is k is equal to 0. I will go back up and we can cross that one off of the list of answer choices. Boom. All right, we've got about 18 minutes left, so let's see what else we can do here. Next question. Well, we got a big table here of discrete values for f and g and the derivative of each. It says the functions f and g are twice differentiable with selected values of f prime g prime as shown in the table. Find the limit as x goes to 1. Well, the first thing that we always try when we're evaluating limits, when you go back to Unit 1, was we always try direct substitution. Now, this question looks to me like it's probably going to be L'Hopital's rule. So you can expect a limit problem to involve some L'Hopital's rule and maybe a little bit of a twist to it that might make it seem a little bit different or unusual to you. But one thing we can always start with here is like, you know what? I have to find out what the limit is or what I get through direct substitution. So we'll try that. So and here's what I'm going to do. Since I suspect that this is a L'Hopital's rule problem, what I really want to do is I want to evaluate the limit of the top. I want to see what this is. And then I'll do it on the bottom separately. So this would be f of -2, because it'd be -2 times 1, minus 8 times 1. F of -2, no surprise, is an 8. 8 minus 8 is 0. Now I'm going to evaluate the limit as x approaches 1 for the expression that's in the denominator, which is 3 times e to the x minus x squared minus 3x cubed. Well, that's going to be 3 times e to the 0 power. That'd be 1 minus 1 squared minus 3 times 1 cubed, or 1. You know what? That's a 0. So really what you get through direct substitution is 0 over 0. And as you learned in Unit 1, that just means it is what we call the indeterminate form of the limit. In other words, we really don't know what the limit is at this point. 0 over 0 means we just don't know yet. We have more work to do. What we taught you in Unit 1, though, was to do some sort of algebra manipulation. And there were several different manipulations algebraically that we had you do. Sometimes it was factor and then divide out common factors and then try the substitution again. Another one was multiplying by a conjugate if there was a radical involved. But when we got into derivatives, after we taught you how to take derivatives, we said, you know what? Going back to Unit 1, there's another technique you can use when you have the indeterminate form of a limit, and that is called L'Hopital's rule. Now, if you do get the indeterminate form of 0 over 0 or infinity over infinity, those are the two indeterminate forms that you will see in Calc AB. There are other indeterminate forms for which L'Hopital's rule applies, but we don't see those really in Calc AB. We'll see more of those maybe in Calc BC or in college in your higher levels of calculus. But it's 0 over 0. So for us, that's a L'Hopital's rule problem. So what I'm going to say so therefore, L'Hopital's rule applies. Because what I just showed, what you do not want to do on your free response questions is show that the limit is equal to 0 over 0. That is a no-no. Most years they're going to dock you a point if you show that, because this is just not a true statement. okay, because this really doesn't mean anything. So what you do want to show, though, is that the limit on the top was 0 and the limit on the bottom was 0. And therefore, L'Hopital's rule applies. And then my next step here would be, I would say so, and I would actually do this. I would take the time to go ahead and rewrite the original statement. The limit of f of negative 2x minus 8x over 3e to the x minus x squared minus 3x cubed is equal to, and now I'm going to take the derivative of the top and bottom. So by L'Hopital's rule, since we proved that we have an indeterminate form with 0 on the top and bottom, what I can do is write the derivative, a new limit of the derivative of the top over the derivative of the bottom. So the derivative of f of negative 2x is negative 2 times f prime of 2x. I had to use the chain rule there. That is a negative 2x on the inside. So the derivative of negative 2x is negative 2. So by the chain rule, there is a negative 2 in the front. You don't want to forget that when you take the derivative of f of negative 2x. Then there's a minus 8. Then down here, the derivative of 3e to the x minus x squared is going to be 3 times e to the x minus x squared. But by the chain rule, I have to multiply by the derivative of x minus x squared. That's 1 minus 2x minus 9x squared when I take the derivative of the negative 3x cubed. So don't forget that the derivative of e, the natural constant e to a power is itself, it is its own derivative, but you do by the chain rule have to multiply by the derivative of the exponent. And so now what I have to do is through direct substitution, see what this is equal to. So through direct substitution, I drop the limit now, and this is going to be negative 2. Now, f prime of negative 2, I have to go up to the table. F prime of negative 2 is a 2. So I replace that with a 2 minus 8. This is going to be 3. This is going to be e to the 0. Right? So I'm going to go ahead and replace that with a 1. When this is going to be a 1, that's going to be a negative 1. This is going to be minus 9. Negative 4 minus 8 is negative 12. I hope this works out. This is negative 3 minus 9. I think it's going to work out. That's a positive 1 is going to be my answer. And I don't think that's a number we've used. I hope it's not. It is not. So far, so good. Okay. So that is a L'Hopital's rule problem that you are very likely to have to use L'Hopital's rule on a free response question. Make sure that, as I said, that you don't show 0 over 0 is equal to anything. Write out separate limits for the top and bottom to show that they are 0. And then you can say L'Hopital's rule applies, which then means you can equate the original limit to the derivative. You could equate that to a limit of the derivative taken on the top over the derivative of the denominator. And then once again, use direct substitution. Here is the next one that's really asking you to see whether you know how to use the chain rule in kind of a function notation context. So the first thing that I'm going to do is I am going to find h prime of x. And then I'll find h prime of 3. So you take the derivative of the outer and leave the inner alone. But then you have to multiply by the derivative of the inside part. So pretty straightforward problem. H prime of 3 is going to be f prime of g of 3 times g prime of 3. And then we have to go get some values. So we got to go get g of 3. G of 3 is negative 2. So I'm going to write it like this, f prime of negative 2. I'm just simply, my first step is to replace the g of 3 with f of negative 2. I will go ahead and get the g prime of 3, which is a 4 right here. G prime 3, I'm using that value of 4. And then f prime of negative 2 is a 2. So this is 2 times 4. 8 is my answer to letter H. And we're in luck. Okay, so we got 2 questions left. The numbers 2 and 5. Looks like that's going to be our last 2 answers here for I and J. All right, this is a great problem here, right? This, if you haven't practiced these and don't know what to do here, these could really throw you for a loop. This is a U substitution problem. So what I'm going to do, since I have an inner part to this, I am going to say that u is 2x. Take the derivative. That would be 2 dx. So therefore, dx is going to be 1/2 du. What I'm going to do next is I am going to create a new integral. I'm going to change these limits to u values. So because these are x values right now, since my variable of integration is x, these are x values. So when x is a negative 1, u would be negative 2. And when x is a 2, u would be a 4. This would be g prime of 4, or excuse me, g prime of u. All right, so we replace the 2x with u, and the dx is going to get replaced with 1/2 du. I will go ahead and pull the 1/2 out to the front as a constant, and then stick the du there. And then when I take the antiderivative, well, the antiderivative of g prime is going to be g of u. And I would evaluate that using the fundamental theorem of calculus from a u value of negative 2 to 4. And therefore, this is going to be 1/2 times, right, that 1/2 is going to stay out here, waiting for me to do g of 4 minus g of negative 2. There's our 1/2. We can go up to the table and get g of 4. Here's my g of x. G of 4 is a 7. So let's put that in there. And g of negative 2 is a 3. Seven minus 3 is 4, times 1/2 is 2. I believe that was one of the 2 unused answers. It was. It looks like we're down to an answer choice of number 5. The graph of p of x is shown in the figure above. Find the average value of p of x over the interval from 0 to 6. The average value of a function is going to be this, right? If you're doing an average value from 0 to 6, you are going to integrate from 0 to 6. But you have to divide by the width of the interval, or multiply by 1 over the width of the interval. In this case, it would be 1 over 6 minus 0. Now, what we're going to do here is we are going to use geometry for this. Because to find this, we don't have a function to integrate, but we know that the integral of a function is the area that is between the function and the x-axis bounded left and right by the limits. So what we're going to do is we're going to find the area from 0 to 5, and then we will find the area from 5 to 6. Now, this right here, how do we want to find this area? I think I'll split it into 2 areas. I could do 3 areas, but I'm going to use a trapezoid and a rectangle. So this is going to be a height of 7 and a width of 3 for the rectangle. So we know this area here is 21. This is a sideways trapezoid. So the formula for the area of a trapezoid is 1/2 times the height of the trapezoid. And this height, and remember, height of a trapezoid is the perpendicular distance between the 2 parallel bases. So it's this distance right here is actually the height of this sideways trapezoid. So the height is 2. And then we are going to sum the bases. So the first base is a 7. And the other base is a 4. All right, but now what we have to do is subtract out this area, because that area is going to be below the, now I'm just going to do an addition, but what I'm going to do is say that the width is 1 and the height is a -2, like that. So this ends up being 21 plus 11. All right, already I don't like what I see here. Plus 11 and then -2. No, I think I do like what I see here. And remember, what I left off of this is there's a 1/6 multiplier here. So this is going to be 32 minus 2 is 30. 1/6 times 30. That was our last number. Okay, we got it. So 10 questions, free response, all answers 0 through 9. And we got it. And there you can see in those problems, we did cover the main themes of the entire class. So it's a good starting place, really, just to review all of the main things. So you've still got students write another, well, I'd say 3 weeks, maybe. Today is the 20th. So 1, 2, yeah, about 3 weeks left before the actual AP exam. So what you want to be doing to prepare, say, do you have a question? Tell me what you were confused about while you're typing your question in there. I'll just say, right, what you want to be focusing in is practicing multiple choice and free response questions, right? It's like preparing for the SAT, right? What do you want to practice on the weeks leading up to the SAT? SAT style questions, right? You have to figure out how those questions are going to look on the SAT. Same now with the AP math problems on AP Calc or Pre-Calc. You want to be looking at problems like the way that you would expect them to look on the exam. Now, it's harder to come across multiple choice questions, right? Those are usually things that are going to have to come from your teacher. You might be able to get a third-party book that has multiple choice questions in it. You can find some older, questions, but the best question is really going to come from your AP classroom that your teacher might release to you to be doing practice between now and the test date. And of course, free response questions are abundant, right? Because they release the free response questions the day after the exam. So there's no mystery as to what's been asked in the prior 20 years on every single AP exam. So you want to be practicing free response questions. And then it's just like anything else in life. You figure out what you know and what you don't know. And if you're working a problem, you don't know how to get the right answer, you've got to get with somebody who can help you figure that out. So that can be your teacher, it could be your classmates, that could be a tutor. another teacher, another calc teacher that's not your teacher at your school, somebody you have to have as a resource. Okay. So anyways, I will be having another live stream 2 weeks from tonight, and I plan on focusing on multiple choice questions. And that'll be at 7 o'clock. So if you're interested, drop in then 2 weeks from tonight. Next week on Sunday night at 7 o'clock, I'm going to be doing another AP Pre-Calc review. And this one is also going to be focusing on multiple choice questions that you could expect to see on the AP Pre-Calc exam in May. All right, so this is Mr. Rich signing off, and hope to see you in a couple of weeks. Take care. Thanks for watching. All right, before I check out here on the area of the trapezoid. Yeah, I don't know. I'll go back to that one, Sadie, before I sign off here. So on the trapezoid here, right? The formula, I guess that's what you're asking me about. The area on the trapezoid, 1/2 height of the trapezoid, sum of the bases, B1, B2. So the trapezoid height is the distance between the two bases, right? So that's going to be a distance of 2. So that was my 1/2 times 2. The bases, this is base 1, 7. This is base 2, 4. So 7 plus 4. So that is the calculation for the area of that trapezoid. Does that help, Sadie? If that's what you were asking about. Okay, good. Awesome, Sadie. Thank you, Sadie, for stopping by and for asking questions. Hope to see you in a couple of weeks. Take care.